Example 1. Classify the following into aromatic, anti-aromatic, non-aromatic. Let's do this on the basis of Huckel's rule. So, on the basis of Huckel's rule, the organic compounds to be aromatic have to follow 4 rules. That is, they should be cyclic, planar in one plane, conjugated meaning alternate either pi bonds or lone pair or plus charge, minus charge, conjugation should be present. And the main thing is that they should be containing 4n plus 2 pi electrons, where n is a whole number, so n can take the value 0, 1, 2, 3, etc. So say for example, if we take n as 0, then we get 2 pi electrons. If we take n as 1, we get 6 pi electrons, so on 12 pi electrons and so on. If the compounds are anti-aromatic, then we can tell that because they will be cyclic, planar, conjugated, but they differ in the 4th rule. Now they will be having only 4n pi electrons, so 2 electrons less, multiples of 4. Once again, here n is a whole number, so we can put here the values of pi electrons would be 4, 8, 12, etc. multiples of 4. Non-aromatic systems are the ones which will not agree in one or more of these. One or more will not be agreed. It will not be cyclic only or planar or conjugated. Then we call those systems as non-aromatic. This is according to Huckel's rule. Now for each of these compounds, let's check whether they fall under which category. So the first one here, this compound, we can see that this pi bond and there is a single bond and pi bond, then we have a single bond. Now if we consider the lone pair of electrons, then we can see that once again we have a single bond and pi bond repeat. So if we consider the lone pair of electrons, then we can say that this system is aromatic because it is completely conjugated. It is anyway cyclic, it is planar, it is conjugated also because we have pi, pi and lone pair here present at alternate positions, and it obeys 4n plus 2 pi electrons because we have 4 pi electrons from 2 pi bonds and 1 lone pair, total giving us 6 pi electrons. So it is aromatic. Considering the next system here, here also we have a pi bond, single bond, pi bond, single bond. We should consider this. Then once again single bond, pi bond. So it is completely conjugated. And once again when we count the pi electrons, we can see that there are 6 pi electrons. 2 here, 4 and this 5, 6. So it is also aromatic. In the third example, this is a pi bond here, single bond here. Let's consider the lone pair on oxygen, single bond, pi bond. But then we have 2 single bonds coming here. Therefore, this system is not conjugated and hence we will call this, if it is not conjugated itself, then we will call it as non-aromatic. For the next system here, we should be once again considering the lone pair of electrons on oxygen. Then we have a pi bond, single bond, lone pair, single bond, pi bond, single bond, plus charge, single bond. So when we consider conjugation, there are 5 types. So we can consider pi-pi, pi lone pair, pi carbon ion, pi carbocation, all these pi free radical, all of them can be considered here. So here This is a completely conjugated system. The total number of pi electrons is 2 here, 2 here and 2 here, 6 pi electrons. We should not consider plus charge because it means there is absence of electrons. So 6 pi electrons, meaning the system is also aromatic in nature. Let's proceed to fifth one. So we should be considering lone pair here and here. This gives us 8 pi electrons and hence it is anti-aromatic. The next one here, for conjugation we should be considering lone pair of electrons on oxygen, giving us 4 pi electrons, once again anti-aromatic. The difference between the sixth one and the seventh one is in the seventh one, here we don't have oxygen with a lone pair, rather we have a carbon with a plus charge. So here the system is conjugated like the previous one, but the difference is the pi electrons is only 2 and hence this is an aromatic system. Proceeding next here to this system, eighth one, there is a perfect conjugation between the 3 pi bonds and hence there are 6 pi electrons and it is aromatic. In the next system, we should consider the lone pair on nitrogen, otherwise the system will not be conjugated. If we consider the lone pair on nitrogen, we get 8 pi electrons, hence we should classify it as anti-aromatic. In the next example, we should consider the lone pair on this nitrogen, but not the lone pair on this nitrogen for conjugation. So this lone pair, this pi bond itself is coming alternate. Hence there are 6 pi electrons. Hence we can call it as aromatic. In the example 11, we see that one of the system has 1 pi bond. If only it had a positive charge, then it would be aromatic. And this system has 4 pi electrons. If it had a negative charge, it would also be aromatic. So what happens here is that if this pi electrons, it comes here on this carbon, negative charge comes, this carbon automatically gets a positive charge. Hence we can see that both the rings here are aromatic. This one contains 2 pi electrons and this one contains 6 pi electrons. In the next example, we see that conjugation itself is not present, hence this is a non-aromatic system. We can see here continuous single bonds. In the next example, same problem is there, that is, we can see that here we have a single bond, once more we have a single bond here, so this would also come under non-aromatic. This way we can classify these compounds by knowing those 4 points of Huckel's rule. If cyclic, conjugated and planar and 4n plus 2 pi electrons, then we classify as